Tectonic plates. Here you are at step 2, tectonic plates. Here you will discover the journey of the continents during the long geological history of our planet Earth. You will also follow the formation of the Alps, linked to the convergence of two tectonic plates, the African plate and the European plate. The continents you know today did not have the same location or shape millions of years ago. They move over time. During their movements, they can collide and create landforms like the Alps, or they move away and leave room for oceans. The history of the Alps is intimately connected to the opening and closing of an ocean. This is a complex story spanning millions of years that can be told in 5 simplified stages. Stage 1. The tear of the Pangea. $250 million years ago, all the continents were joined together in one huge continent called Pangea, surrounded by an immense sea called the Panthalassa. Then, this great continent slowly breaks into 2 parts, the Laurasia in the north and the Gondwana in the south. This separation leads to the creation of an ocean, the Tethys. Stage 2. The expansion of the ocean. The 2 continents, Laurasia and Gondwana, separate and break up into smaller blocks. The Tethys continues to grow, applying pressure to the 2 continental plates. Millions of years later, part of the seabed will become the Wallis soil. This is why we find serpentinites and cushion lava in the region of Zermatt, at the bottom of the Val d'Arance and the Val d'Aniviers, but also fossils of ammonites, belemnites, and sharks. These rocks and fossils bear witness to the very early presence of an ancient ocean, the Tethys Ocean. From geological observations, one can imagine the landscape of the Wallis at that time. A warm and dry climate with sand dunes, chains of mountains surrounding volcanoes, massive rivers, and saurians going here and there, leaving fossil traces that we can find today. Stage 3. Subduction and closure of the ocean. The opening of the North Atlantic Ocean drives Iberia as it separates from Europe. We are witnessing the birth of the Valais Basin. There is also a small plate called Apulia. Apulia originally belonged to the African continent, which is getting closer to Europe. The movement of Apulia towards Europe triggers the closure of the ocean Tethys, also called the Piedmontese. The subduction begins under Apulia. The opening of the North Atlantic Ocean in turn drives Europe towards Apulia, while the rotation of Africa pushes Apulia towards Europe. During 50 million years of subduction, the Piedmontese Ocean, the Briançonnais microcontinent, the Valais Basin, and the European coasts will dive under Apulia. This subduction zone is at the origin of the creation of the Alps. Stage 4. Collision between Europe and Africa. Here is a section of the subduction zone between Apulia and Europe. Here, the tip of the oceanic plate that has separated from the ocean ridge cools, becomes loaded with water and sediment, and increases in thickness and density. It then plunges slowly into subduction under Apulia. Subduction continues for millions of years. The oceanic plate sinks, and sediment from the Piedmontese Ocean, from the Briançonnais Ocean, and the Valais Ocean all build up. These rocks and sediments are compressed against the continental Apulian plate, which continues its rise towards Europe. The continental Apulian plate collides with the European plate, and this is at the origin of the creation of the first alpine landmasses. This simplified section shows that the Matterhorn consists of a stack of 3 rocks: the European crust under the oceanic crust, itself under the African crust. Stage 5. The rise of the Alps. For the last 45 million years, the Alps have continued to rise. About 35 million years ago, the Alps were higher. But erosion sculpts the mountains over time. Torrents and rivers gradually erode rocks, giving birth to valleys. For the last 2 million years, glaciers have contributed to this erosion, sculpting the mountain and sometimes revealing rocks buried during the subduction, with their fossils and their history. It is possible to find traces of dinosaurs in the Wallis, in Emerson, for example, where we can observe, engraved in clay, the footprints of a herd of dinosaurs, as well as marine fossils on top of mountains like the Eger or the Monch. Today, the Alps continue to rise. The regions around Brig and Coire rise at a rate of up to 1.5 millimeters per year. But this growth is offset against the effects of erosion. To finish off, let's watch a short film that retraces the course of the continents over the last 280 million years.